Okay, guys, let's take a look at these problems that you guys are working on, where you're finding the areas of, some of the irregular figures here. All right, let's start with problem number one. It says to find the area of the figure, use 3.14 for pi and round your answer to the nearest tenth. Okay, well, to find the area of this figure, you want to split this figure into different pieces. So we're going to call this figure 1, call that figure 2. Area 1, we know, is a rectangle, so we're going to use the formula length times the width. So area 1 is going to be equal to, the length is 6 and the width is 3. So that's going to be 6 times 3. So area 1 is going to be equal to 18, and those are square meters. And then we have area 2. Area 2 is a semicircle, right? And that's this figure, this space here. Semicircle is half the area of a circle. So if we start with the formula for the area of a circle, which is pi times the radius squared, and then we're going to take half of that by dividing that pi times r squared by 2. So area 2 is going to be equal to, we're told to use 3.14 for pi. Now, what's the radius of this circle here? Well, let's explore that a bit. We know that this segment here is 3, which is the same as this segment here. So that means that the diameter of the semicircle is 3. We know that the radius is half the diameter, so half of 3 would be 1.5. So that's what we're going to have to use for the radius. So we go back to our formula, and that's going to have to be 1.5. We're going to square that, then we divide that by 2. Now with your calculator, you have to do the 1.5 squared first in your calculator. So I'm going to do 1.5 times 1.5. That's going to give me 2.25. And then we take the 2.25, multiply it by 3.14, and then we want to divide that product by 2. That's going to give us 3.5325. So area 2 is going to be equal to 3.5325. The total area is area 1 plus area 2, so we have to add the 18, which is our area 1, to that, and then we wind up with 21.5325. Alright, and that's going to be answer C. Alright, that's going to be 21.5. Those are going to be meters squared. And it's 21.5 because we're rounding that to the nearest tenth. So we get answer C for problem number 1. Okay, let's look at problem number 2. It's simply the area of the circle, but we're given the diameter here. So we start with the area is going to be pi times the radius squared. Area is going to be equal to, we're going to use 3.14 for pi. The radius is going to be half of 36. So if the diameter is 36, the radius is half of that, so the radius is going to be 18. Then we're going to have to square that. So the area is going to be equal to 18 squared. So with your calculators, you're going to multiply 18 times 18. It's going to give you 324, but then you multiply that by pi, 3.14, and we wind up with 1017.36. And that's going to be, let's see, oh, right, I don't see anything that's the exact answer, but I do see 1017 here and 1017 here. Now, what's the difference, or what's the reason for the difference in answers? The reason is, what are we using for the approximation for pi? Different calculators, different computers, different texts going to use different approximations for pi. So our approximation of 3.14 gives us this answer in square centimeters. So you want to choose the answer that's closest, and that's going to be answer B. Okay, let's take a look at answer C, or problem C. We're trying to find the area of a circle. Alright, so area is going to be equal to pi times the radius squared. We're given the radius this time is 5, so the area is going to be equal to 3.14 times the radius, which is 5, and we're squaring that. So with your calculator, you're going to do your 5 squared, which is 5 times 5. Right, so that's going to be 25. and then you multiply that by 3.14, and we wound up with 78.5. So the area is going to be equal to 78.5. Those are square meters. That's going to be answer A. Alright, let's move on. The drawing is composed of a rectangle and a semicircle. Find the area of the figure to the nearest tenth. We're going to call the rectangle area 1. We're going to call the semicircle area 2. We want to find the area of those two figures combined. Area 1, because it's a rectangle, we're going to use length times width. Area 1 is going to be equal to, well, it looks like we have a length of 7 and a width of 19. So that's going to be 7 times 19. So area 1 is going to be equal to what? 7 times 19. Right, use your calculators. It's 133. And those are square centimeters. But that's just area 1, which is the area of the rectangle. We still have to find area 2 and add it to area 1. Area 2 is a semicircle, which is half the area of a circle. So we start with our formula for the area of a circle, which is pi times the radius squared. Then we're going to take half of that because we're looking at the area of a semicircle. So area 2 is going to be equal to 3.14 times the radius squared. Well, what's the radius? Well, this segment here is 19, which means that the diameter is 19. The radius is going to be half of that diameter. So what's half of 19? That's going to be 9.5 for the radius. Alright, so we're going to have 9.5. We're going to have to square that. Then we're going to divide that by 2. So with your calculators, make sure you do 9.5 times 9.5 first, because we have to follow the order of operations. 9.5 times 9.5 is 90.25, and then we want to multiply that by 3.14, and then we want to divide that by 2. That's going to give us 141 for area 2. We get 141.6925, and those are centimeters squared. But we need the total area, so I want to add 133 to that. Right, so I'm going to add area 1, which is the 133, and we wind up with 274.6925. Right, so I'm looking for the closest answer, because when we're dealing with pi or problems that use pi, sometimes our answer is going to be a little different, right? But it looks like they went to the nearest whole number. Our answer to the nearest whole number is 275. That's going to be answer D. Okay, let's try problem 5. Problem 5, we're looking for the exact area of the circle for problem 6 and 7, where we write our answer in terms of pi, which means we're not going to use an approximation for pi. Well, what does that mean? Well, let's take a look. Areas of a circle is pi times the radius squared. Area is going to be equal to pi, right? We're not going to approximate it at 3.14. We're going to use pi. The radius is 9. We're going to have to square that. So the area is going to be equal to 9 squared is 81 times pi. There's our answer. Right? When we're doing the math in terms of pi, it's actually a bit easier because we don't need a calculator for the most part. Right? We don't have to approximate pi, so we get 81 pi, and these are inches squared for our units. So that's going to be answer A for question 5. Question 6, same type of problem, but we're given a diameter. Right? Area is going to be equal to pi times the radius squared. So area is going to be equal to pi. Now what's the radius? Well, we're given the diameter of 6. So if we're given the diameter of 6, means that our radius is going to be 3. So it's going to be 3 squared. So the area is going to be equal to 3 squared is 9. So 9 times pi would be our answer in terms of pi, which is an exact answer because we're not using an approximation for pi. So 9 times pi is going to be our answer, and that's answer B for question 6. All right, question 7 says a field is to be fertilized at a cost of 14 cents per square yard. The rectangular part of the field is 125 yards long, so let's write that in. That's 125 yards long, and the diameter of each semicircle is 45 yards. Okay, so we know the diameter of the semicircle is 45, which is also the width of the football field as well. Find the cost of fertilizing the field. Use 3.14 for pi. Okay, well, let's take a look and see what that means. Let's call the rectangle area 1. Let's call the semicircular area area 2. Area 1, because it's a rectangle, we're going to use length times width. Area 1 is going to be equal to 125 times 45. So area 1 is going to be equal to, let's see, 125 times 45, wind up with 5,625, and those are square yards. But then we still have the area of the circular part. Okay, we're going to call that area 2. Area 2 is pi times the radius squared. So area 2 is going to be equal to, we're told to use 3.14 for pi. Our radius is what? Well, if our diameter is 45, half of 45 is 22.5. All right, I'm going to run out of room here, so this is going to be times. I'm going to put times here. Put my 22.5 down here. All right, and we're going to have to square that. All right, so pi times r squared. So first we want to take the 22.5, we want to multiply that by 22.5, we want to square that. It's going to give us 506.25 times 3.14. That's going to give us 1,589. Area 2 is going to be equal to, let's see, 1,000. 1,000, what is that? 589. 589.625. Alright. Now, those are square yards. I just want to double check this answer here, because 45 times 100. Oh, no, that's right. Okay. So now, we have to find the total area, so we need to add those two together. So we have 5,625 plus the 1,589, so we plus 5,625. Right, so I'm going to add these two together, and I get a total area of 7,214.6, and those are what? Square yards. Now, they're asking about the cost. All right, the field is to be fertilized at a cost of 14 cents per square yard. So if I want to find the cost, I just have to take our total area and multiply that by 14 cents. And we wind up with $1,010.05. All right, that's going to be equal to $1,010, and if we round to the hundredths, 5 cents, and that's going to be answer A for question 7. All right, so just take a look at your work. All right, you start by finding area 1, which is a rectangle, area 2, which is a circle. We have to then add those areas together, and that's where we get the total area from. And then that total area, we just have to multiply by the 14 cents per square yard, and that's where we get our cost. Okay, next example. The diagram shows a square side of 4 inches containing a circle with a diameter of 4 inches to the nearest hundredth. What's the area of the shaded part of the figure? Okay, well, each of these is 4, and we know that the diameter is 4. So first we have to find the area of the square. Okay, so the area of the square is going to be equal to 4 times 4, or 4 squared. So the area of the square is going to be equal to 16. Oops, going to be 16 square inches for the area of the square. Then we need to find the area of the circle, which is going to be pi times r squared. Area of the circle is going to be equal to 3.14, our approximation for pi. What's the radius? Well, if the diameter is 4, the radius is going to be half that. So the radius is going to be 2, and we're going to square that. So 2 squared is 4. So we have 4 times 3.14. That's going to be 12.56. So we have the area of the circle is going to be equal to 12.56. And those are square inches. Let's see, yes, square inches. Now we're just looking for the area that's shaded. Well, the area that's shaded is, let's play with this a little bit. Get my highlighter function here. Okay. Here's area 1. Area 1 is that entire square that I just filled in. Right, so that entire yellow area is 16. Then we found the area of the circle. Now the area of the circle, I just erased, or I erased a lot of it. The area of the circle, if I take it away, I'm going to have 4 of these corners left. We only want one of those corners. So my next step with this math is to subtract those two numbers. Oops, I didn't want to do that. Okay, I want to subtract those two numbers. So when I subtract the 16 and the 12.56, we get 3.44, but then we have to divide that by 4 because I only want one of those 4 spaces. So I want to divide that 3.44 by 4, so I want to divide that by 4, and I get, oops, I get 0.86, and those are what, square inches. Alright, that should be 0.86 square inches. Alright? And then this last one here. At the Magic Garden, a rose garden is being designed as shown. The outer figure is a square with side lengths of 116 feet. So this is 116, this is 116. What's the diameter of one of the circles? Well, if this whole red distance is 116, the diameter is going to be half of that. So what's half of 116? Well, if we take 116 and divide it by 2, that's going to be what, 58? So part A, right, that's simply 58 feet for part A. And that's all you had to do there, right? To find the diameter, we just take half of that 116, and if we divide 116 by 2, right, that's where we get the 58 from. Part B is going to require a little bit more work. It says the roses are to be planted in 4 circles. The rest of the space will be covered in wood chips. What's the area of the surface that will be covered by wood chips, and explain how you found your answer. Okay, well, similar to some of the problems we've done, we first have to find the area of the square, which is going to be equal to the 116 times 116, or 116 squared. So 116 times 116, that's going to give us the area of the square. It's going to be equal to 13,456. Those are square feet. Okay, that's step 1. But then we need the area of the circles, right? The area of the circles, but there's 4 of them. So the area of the circle is going to be pi times r squared, but because there are 4 of those circles, we're going to multiply the pi times r squared by 4. So the area of the circles is going to be equal to 4 times the 3.14 times the radius squared. Well, what's the radius? Well, we answered part A as the diameter of one of those is 58 feet. Well, the radius is going to be the 58 feet divided by 2. So 58 divided by 2, that means that the radius, and I'll draw it in here, the radius is going to be 29. Alright, so the area of the circle is going to be equal to, you want to do your 29 squared, so 29 times 29, and then you want to multiply that by 4, and then times 3.14. That's going to give you 10,562.96, 62.96. We're going to make that 10,563. Let's just round that to the nearest whole number. Okay? And then the area that's going to be covered by wood chips is simply the difference between those. So we're going to have to subtract the 10,563 right, from the area of the square. So we subtract 13,456 and the 10,563, and we wind up with 2,893.0, or let's see, 90, yeah, we'll leave it at 93.0, that's fine. Or just 2,893 would be fine. All right, and then we wind up with, and those are what units? Feet, square feet. All right, so we had a bunch of different problems there, right? Just make sure you organize your information, you try to label everything, and if we're trying to find the area of composite figures, which is really our next lesson too, you're going to have to separate figures into different shapes, and just be careful with your calculations. All right, good luck.